Okay, hello. Welcome to Unit 2 of Geometry. We've been talking about angles and line segments and all that. So right now we're going to get into some parallel lines. So by the end of this video, I hope that the viewer will be able to identify special angle relationships, and they are those. Now you already know the linear pair and supplementary and vertical. We don't know corresponding or anything else yet, but we will. All right, so first of all, parallel lines are everywhere, literally everywhere. Railroads, football fields, I almost just said sports fields. Football fields, um, swimming lanes, the lines are green, and then this symbol means that it's parallel all to each other. So when another line intersects with the parallel lines, it's called a transversal. So the red line is the transversal. What's it called? The transversal. Yes. Again, rivers are parallel, sometimes, not perfectly. So the parallel line markings are these arrows. What's this line called? The intersecting line? Transversal. Yes. So two things we really need to talk about. Well, we have a lot of vocabulary. This whole unit is actually geometry is so vocabulary heavy, but one thing that people get mixed up is interior. So the hamburger is on the interior because it's all squished up in there between the lines. So angles A, B, C, and D are on the exterior, and the hamburger's on the interior. The hot dogs here are the parallels, the dotted transversal line. The hot dogs are on the exterior of the parallels, and angles 3, 4, 5, and 6 are on the interior. That's really important. Exterior, interior, inside, interior, exterior, outside. So there are angles that are created by the transversal. So see this angle 1. It's talking from here all the way to here is some degree. Now, just to review, is that acute or obtuse? Obtuse, because it's bigger than 90 degrees. If it were 90, this transversal would just go straight up, but it's not. And then angle 2 is acute, and you can unlock information about the angles based on which ones that you're given and then their relationship to one another. So that's why we're learning about angle relationships, because once you know in this sort of situation, 1, 2, 3, even though it's not listed, 4, 5, and 6, 7, and 8, if you know any one of these angles, how big it is, how many degrees it is, you can like dominoes, just boom, 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 start knocking them all out. You can find all of the angles if you just have one. So, for example, angle 1 and angle 2 together make a line, boom. And that's the line. How many degrees in a line? 180. Exactly. Half of a circle. But wait, stop. We already know some angles. We're going to start with those because remember, learning is all about making connections to stuff that you already know. So also, can you spot the parallels in here? This one's parallel with, oh, I don't know if you can see my cursor. Maybe I'll write. This is parallel to this. Whoa. Those are different colors. Okay, whatever. This is parallel to this. Oh, it's just a highlighter, that's why. Okay. Etc. So we already know supplementary angles and linear pairs. It's the same thing. It's anytime, so here's one, and here's one. Those are both 90 degrees, and they make a line. Linear pair, or supplementary. It's any two angles that sum or add up to 180 degrees. So this one and this one, you really can't see that. That's acute. That's obtuse. Together they equal 180 degrees. All right, so it's corny, but I've got a special way to like remember all of these things because memorizing is hard. You need some strategies to memorize well, and one of them is association. So you can associate or like link together in your mind the relationships with like something that they remind you of. Since I'm doing this video, it's just going to be something that it reminds me of, but you can come up with your own strategies. So linear pair, what it looks like on parallel lines cut by a transversal is this. So 1 and 2 are a linear pair, and also 7 and 8 are a linear pair. But here are the tricky ones. 4 and 2, right here and here, also together make a line, but it's like a flipped line, so watch out for those. And I call them BFFs because they're like right next to each other. So whenever they're like 2 and 1, I wonder if, nope, I can't go backwards. Okay, so 1 and 2 are right next to each other. 2 and 4 are right next to each other, so they're like BFFs, best friends forever. Okay, quick check. Are angles 2 and 4 congruent? Are they equal? And then why or why not? So 2 is an acute angle, while 4 is an obtuse angle. So no, they're not congruent. All right, you guys remember this one? My favorite, the railroad. Starts with a V. Don't say vertex. Vertical. Vertical angles, and they're congruent. So this one is congruent to this one. Oh, can't see that. Bum, bum, is congruent to this one. Bum, bum. And then this angle is congruent to that angle. Easy, right? You already know those. What does it look like on a parallel? There's still railroads because you still have this X. And it's still this one congruent with this one. And this, well, I'll do it like that. This one congruent with that one. So if that's 50 and that's 50, this, because of this linear pair right here, we know that this has to be 130 because linear pairs, any two angles that add up to 180 degrees or a line. So there's 2 sets or 4 total angles that are vertical here, but they're only vertical with each other. All right, 130, 130, boom, ba-dum. These are vertical, the red dots are vertical. They are equal to each other. And it's like the X railroad. You already know that one. All right, here are the new ones. So, corresponding. Oh no, I didn't want this part in here. This part in here yet, but oh well. So, one of my students, actually I'll shout him out. What up, Marcel? I hope you're watching this. Cell. But he told me today, he's like, oh yeah, like the shadow one. And I'm like, oh my gosh, I've never heard anyone explain it like that. And it's perfect. So here's a transversal. Here's a parallel line. Here's another parallel line. Here's a man in a wheelchair. Here's a man in a wheelchair. He's talking about, or he's signifying this obtuse angle and this obtuse angle. So do you see how they're kind of matching? Or it's like a shadow if the sun were up here. And And, well, that wouldn't exactly be it. It needed to be a little bit more up, but whatever. So he's like, this guy is creating this shadow. So this guy is riding on top of the parallel line, and this guy is riding on top of the parallel line. And both of them are to the right side of the transversal. So they're both on top of a parallel and to the right of the transversal. So they're in matching positions, or like shadow positions, or the same position, in corresponding. Corresponding means matching, or like they go together. So yeah, I always think of them as matching. You can think of them as shadow, or whatever memorization strategy you come up with. So the Z, this is Melrose's favorite. She draws a Z. And then whatever angle is on the inside, like if you clamped the Z together, what would get smushed? So it's not this one. This one's not going to get smushed. If this comes down, the 3 is going to come over here and get smushed. I guess, well, whatever. It would push the 4 and 5 out of the way. Let's think of it that way. So angle 3 and angle 6 are called alternate interior angles. Now also, 4 and 5 are alternate interior as well. And it's because they're on alternate or opposite sides of the transversal. So that's another vocab word. People get super confused on these angle relationships just because of something as silly as just not knowing what like alternate or corresponding or interior means. Like that's no reason. That's not math's issue. There's no reason to not know these things, because alternate, it's like, I don't know if they use this phrase in sports, but I'm going to say, like in sports, when and if you can't do something, maybe they'll like put an alternate in, like if you get hurt. So you're out and the opposite person is in. You could think of it that way. Or a different person. So different sides of the transversal, opposite sides of the transversal, but they are also on the interior, like the hamburger was, of the parallel lines. So this whole area here is the interior. Inside, interior. And then the Z again, and so they're congruent. They're both 50. And doesn't that make sense? Doesn't this look acute? And this one looks acute. And then over here, I'll do it in, how about blue? This obtuse, this obtuse. So alternate interiors are always matching. I should not use that word because that was our word for corresponding, but they always are the same angle measurement. Alternate, opposite, interior, inside. Opposite sides of the transversal, inside the parallels. All right, I like this one a lot. And only after I came up with this memorization strategy, or like association. So like they're snuggled, same side of the transversal, inside. So here's a lovely lady. Here's a manic man. I don't know. Flipped upside down man. They are both on the same side of the transversal, so they're on the right side. And they're interior, they're on the inside of the parallels. So they're all snuggled up right next to each other. This is not, whoops, oh no! Okay, well, it's not to be confused with the linear pair. They're also right next to each other, but that's like BFF land when they're snuggled up in between. I'll just do it for a moment, like this one and this one. When they're snuggled up right next to each other, you can think of this as like a fence, and this is a fence, and they're squishing together, and then the people are going to hit each other. That's like the same side interior. All right, however, now we're back to alternate and not interior this time. It's not the Z. It's like alternate opposite sides of the transversal. So left side, right side. Exterior, they're on the outside. So I forget what comes next. Okay, so 1 and 8 are on opposite sides of the transversal, and on the exterior, on the outside of the parallel lines, not on the inside, not on the inside. All right, why do I call it googly eyes? I think of like a frog with those big eyes, and they're both supposed to be here, right? Like, I hear, but psych, it's not. It's on the other side. It's all googly. Googly eyes, alternate exterior. Okay. Oh my gosh, I love this one too. Okay, so like look at the dogs. Same side of the transversal on the exterior of the parallels. Here's how you can remember it. Same side of the transversal, outside of the parallels. No, not on the inside. It's like a dog's playing his legs out. God, I'm so clever. Gosh, I'm so clever. Okay, so here's a quiz. For this quiz, it's just going to be what's the angle relationship. It's not like a quiz, it's just a check for understanding. So it's like, what's the angle relationship? And then if you can guess, I'm going to give you a little bit. So you're going to have to be like pausing and continuing, because I'm not going to have like very much wait time between when I ask the question and then just when I just tell you the answer. Okay, so what's this angle relationship? And then also, do you think that they're equal, or do you think that together they equal 180? Railroad, vertical, here equals here, so they are congruent. Verticals are congruent. All right, so let's just look at the 133s, the obtuse ones. What's the angle relationship? And are they equal, or do they equal 180? Pause and go. Boom! Shadow angles. They're corresponding. Corresponding, look, they're both 133. Correspondings are congruent. That looks supposed to be kind of like that. All right, what's this angle relationship? Okay, I'm going to help you. The Z. Boom, alternate interior. Alternate sides of the transversal inside the parallels. All right, snuggled up close. Well, they're not snuggled. They're just friends because they're separated by this line, so they're not actually snuggled. They're BFFs. Linear pair. All right, now just look at them. This angle, acute or obtuse? Obtuse. This angle, acute or obtuse? Acute. Obtuse, acute. If one's obtuse and one's acute, they cannot be equal. But we know that they together make a line, so they are supplementary. Together they equal 180 degrees. This one's too easy. Alternate interior, Z, and we know that they are congruent. Shoot, this stinking one already has the answer. Okay, well, it's corresponding. So actually, I'm glad. Okay, so do you see this? A different memorization strategy that you might want is the F. So you can make an F, and if the two angles created there, those are going to be corresponding or matching or shadow angles. The F, notice, can can also, whoa, that was not straight. Can also be upside down. And look, they're both 130, that one's both 170, therefore congruent. Corresponding angles are congruent. Corresponding congruent, CC. All right, what's this? They're right next to each other, but are they? Are they separated by a line? What could they be? They're not alternating the side of the ooh, notice this one, by the way. We have one transversal and we have a second transversal. So this is going to be like a little bit more complex of a question when we get into the work, when we get algebra involved too. So, okay, I'm talking too much, sorry. So here's an angle, here's an angle. What's their relationship? Same side interior, snuggling up. Now naturally, look, 130 and 50, that's not the same angle measurement. That's acute, that's obtuse. Boom, 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 boom. So it's going to be equaling 180 degrees together. All right, we got some googly eyes. Same side? Inside? Opposite sides? Outside? What is it? What's going on here? Alternate exterior. They're not on the inside. All right, just a few more. What's the relationship between angle 3 and angle 4? Vertical railroads, here's the X. And verticals are congruent. And look, you can just tell, obtuse, obtuse. Okay, here's the ultimate quiz. So pause, write down, write it in your notes on your phone, scrap piece of paper, wherever you want. Try this and then push play again. All right, welcome back. Here are the answers. Now we're going to go down. So first one, linear pair, angle 1 and 2. Here's angle 1, here's angle 2. Boom. Together they make a semicircle or a line. All right, number 2, vertical railroad sign. Angle 1, angle 3. Houston, we have an X, so they are vertical, and verticals are congruent. Number 3, angle 3 and angle 2. Here's angle 3, and here's angle 2. Bum bum, the sneaky linear pair. I'm going to switch to that color. Oh, that's not the color I wanted. They make a line, angle 2 and angle 3, boom. Also make a line, but it's a sneaky line, 180 degrees. Linear pairs are supplementary. Together they equal 180 degrees. Number 4, same side interior. So for angle 3 and angle 6. So here is angle 3, here is angle 6. They almost look like corresponding, but they're not. They're snuggled up close to each other right there with no line in between them. Next one, alternate interior. Here's angle 3 and angle 5 on the opposite sides of the transversal. And notice your Z can go backwards. It can be a backwards Z. And they are congruent. Alternate interior angles are congruent. Then we got corresponding. So here's angle 3, here's angle 7. They are both on the bottom of the parallel and to the right of the transversal. They're both on the bottom of the parallel and to the right of the transversal. So they match, they create a shadow, it's corresponding. All right, oops, I hit that too fast. But 7 and 1, here's 7, Boom, here's 1. They are on the opposite sides of the transversal and not on the inside, on the outside. So it's like his googly eye, which should be numbered, or his regular eye, it'd still be bug-eyed, but it would be angle 2, but it got mixed up, so therefore we've got a Google eye, because this eye got kicked over here. Okay, I did it again, I hit it, I didn't mean to, so this one, same side, exterior, here was angle 7, and same side, exterior, what do you think it's gonna be? It's gonna be angle 2, boom, boom. So same side, exterior, oh, well, I guess that was listed in the question. Okay, how'd you do? Did the memorization strategies help? I hope so. I'm looking forward to hearing what you guys think about that. And one more thing, and I promise this is the last slide. So here we go. So only 3 of these are you ever going to really have to worry about setting the angles up to 180 degrees. So it's a linear pair, like 1 and 2 work together, they make, boom, a line. Or same side interior, boom, boom. Now 6 is acute, 3 is obtuse. They cannot be the same. They've got to equal 180. And then we've got same side exterior. 2 is acute, 7 is obtuse. They cannot be equal, therefore together they must equal 180. Alright, I made a kind of a slight error here. But it really wasn't an error. It's just that I just was using a theoretical angle 1 and angle 2, but this one needs to be switched to angle, I need to make my pen bigger. This needs to be angle 3. That's what I'm. Angle 3. Okay. So let's just, I guess, keep on this color here. Angle 1 equals angle 3, or angle 3 equals angle 1. So all of the other relationships are going to be congruent. So you can just even see that. Look, 1 is obtuse, 3 is obtuse. They equal each other. 3 is obtuse, 7, which is corresponding, is obtuse. Boom, they equal each other. I'm going to switch colors for these two. Alternate interior. Let's go the backwards Z. Might as well. This one and this one, look, they're both obtuse. They equal each other. And then this one, alternate exterior, alternate, let's go this one, and then opposite side of the transversal, so I'm coming to the right, and it can't be 2, even though that is exterior. And then down to 3, nope, that's on the interior. 6, nope, that's on the interior. Okay, so 7. 7 is exterior. The reason it can't be 2, even though technically 2 is on the opposite side of the transversal as well, and also on the exterior, the reason is because 2 is a linear pair with 1. It can't be 2 relationships at once. I want to see something. Oh, that would have worked just fine, angle 3. Okay, well, I hope that you enjoyed this, and good luck.